Okay, exercise 4C, finding the distance between 2 points. So let's start with the question. Find the distance between 2, 3 and 5, 7. I'm not going to type out the question again, that was ridiculous. Okay, now we did these kind of questions a little bit in C1, and they were the more challenging questions in C1. So if we just draw a sketch again, so we've got the coordinate 2, 3 down there, and the coordinate 5, 7 up there. And in C1, we looked at using Pythagoras Theorem to solve this kind of question. Okay, because if you draw a horizontal line across in the direction of the x-axis and a vertical line down in the direction of the y-axis, we know there's a right-angled triangle there. Okay, so then we can just use, it becomes a Pythagoras Theorem question from GCSE. Alright, so if we just work out the distances of these two lines, so that's going to be the difference between the x values, 2 and 5, so that'll be 3, and then the other side would be the difference between 3 and 7, the y coordinates, which would be 4. Okay, and obviously the hypotenuse is the line that joins the two coordinates together. So that's going to be the one we're going to solve. So not only is it a Pythagoras Theorem question, but it's one of the easiest types of Pythagoras Theorem question you can have. So that's the hypotenuse squared, x, is equal to 4 squared plus 3 squared. That's going to give us x squared is equal to 16 plus 9, which is equal to 25. So x is equal to root 25. So x would be equal to 5. So the length of the line joining those 2 points would be 5. Right, so what I want to do now is try to find a formula for finding the distance between 2 points by doing exactly the same as we've just done, but using algebra instead. Okay, and this is an example of a mathematical proof. So if we do the same question but with letters, then we can just plug in any numbers in for those letters, and it'll just make the process of finding the distance between 2 points a lot easier for us. So if we just like we did with the gradients, if we call the one point x1, y1, and the other point x2, y2, and then we just go through the process that we did for working that out with Pythagoras Theorem. Okay, so we need the distance between the x values to get the length of that line there, and the distance between the y values to get that line there, and that will give us, that's the hypotenuse we'll call d, because we're trying to work out the distance between the 2 points. So the bottom, that side there, is going to be the difference between the x's and the difference of the y's. Okay, so if we just write that in, I think, yeah, so that length there is going to be y2 minus y1, and that length there, the bottom one, is going to be x2 take away x1, so literally just the difference between the x values and the y values. Okay, so therefore, using Pythagoras, we can get an expression linking those three sides together. So we know that d squared is going to be equal to the other two sides squared and added together. So x2 minus x1 squared plus y2 minus y1 squared. So therefore, d is just going to be the square root of all of that. So the square root of x squared minus x1 squared, x2 minus x1 squared, sorry, plus y2 minus y1 squared. Okay, so that's mathematically proved the formula for the distance between 2 points. Okay, that's an important formula to remember. So we don't have to worry about drawing sketches and working out Pythagoras' theorem and working out all those sides as we did before. Okay? So as I said, and that's the formula for the distance between 2 points. Okay? Right, let's do an example. Okay, so let's start with the question then. So line PQ is the diameter of a circle where P and Q are minus 1, 3 and 6, minus 3 respectively, and the radius of the circle is what we want to find. So if we do a sketch quickly and then just compare the x coordinates, so we know P is on the left, right is Q is going to be on the right. Compare the Y's, so we know P is going to be here somewhere, Q is going to be down there, and then just randomly sketch them in. Okay. We want to have them opposite each other in the circle as well because we know it's a diameter. We want it to represent what the question is saying. So P is there, -1 and 3. Q will be there, 6 -3. Okay. If we join that up, so we know it's a diameter. Okay. And that's going to go through the center of the circle. Let's just label that diameter. Alright, let's get the center on there. It's just going to be over there. Now linking this back to what we did in the previous lesson as well, if I want to find the coordinate of that center, I can use my midpoint of two coordinates rule as well. Okay. So, and remember my radius, which is what we're going to find, is going to be half of that diameter. So the only two coordinates we've got are P and Q. So if we use our formula for the distance between 2 points, we'll be able to work out what the diameter is. And then once we've got the diameter, we just need to half that and we get the radius. So that would be the plan stage that we talked about in the previous lesson, for you kind of working out what you're going to do to solve the problem. Alright, so if we work out the length of PQ first, that's going to be the square root of the difference in the x's, so 6 minus -1 squared, plus the difference in the y's, so that'll be -3 minus 3 squared. Make sure you do them in the right combination. Alright, so the x's from that one, take away the x's and y's from that one, so make sure we're just doing that. Alright, if you don't get them in the same order, then you could have a problem. Okay, so if we work that out, we'll have PQ is equal to the square root of 7 squared plus -6 squared. So that'll give us the square root of 49 plus 36. -6 times -6 would be 36. And then, so therefore PQ is going to be the square root of 85 therefore the diameter is root 85. There's pointless working that out. It's just going to give us a long decimal number. So just on our calculator, we can work out the radius is equal to square root of 85 divided by 2, which is half the diameter. There's put that there. So if you get a calculator up, work that out and round it to 3 significant figures or whatever it's asked you to in the exam, in the question. Okay. So there's the full number, and then you round it as you need to. So let's round it to 3 significant figures. Alright, done. And that's it. Obviously some of the questions get a little bit harder than that, but just use that same problem solving plan kind of idea that I went through in the last lesson. Alright? Okay, good luck, off you go.